Welcome back, all you cool cats and kittens. We are going to talk about composition functions today. When I say composition, I don't mean like a composer. I spent so much time on this, you guys. This thing is so nice. That's probably the nicest piano I've ever drawn, to be honest with you. But it's beautiful. When I say composition, I don't mean like composer. What I mean is like a composition, like a pile of composite material. What I mean is sticking two things together. So what we're going to do today is we are going to do lessons 0.2 and 0.3 all in a single video because we need to take this at a very brisk pace to make sure we cover all of the material for Algebra 2 before the end of the semester. So normally lesson 2 is just regular composition functions, and then 3 we include evaluating functions with that. So we're just going to learn composition functions and how to evaluate them all in one video to save a little bit of time and a little less pomp and circumstance surrounding the whole ordeal. Okay, so let's go ahead and dive into it. Let's start with some terminology and some instructions on what we're going to do so that we have an idea of how we're going to handle everything before we dive into the meat and potatoes of this whole shindig. So, for composition functions, what a composition function is, it's where we plug one function into another function. What you're going to see typically is something like this. You're going to see f of g of x. And if you want to say this out loud, the way you say this is f of g of x. The reason we teach you this is so that when you go out into the real world and you say stuff, you sound intelligent and like you know what you're talking about, and people will think more highly of you. If you go out there and say f parenthesis g parenthesis x parenthesis parenthesis, that just doesn't quite cut it. It doesn't have the same artistic flair as f of g of x. It doesn't quite roll off the tongue, you know? So this is f of g of x. Another way we can write this in math is like this. This thing is very deceptive. Notice that this dot in the middle is open. There's a little white gap in the middle. It's f open circle g of x. This means exactly the same thing as this. Okay, these are the exact same thing. They are just two different ways to write it. Think of them like synonyms. They are the same thing. But, you know, mathematicians can't make your life easy. Okay, the reason this can be confusing for students is because this looks awfully like this. This means multiply. This one means a composite function. So it's very important to pay attention. Is the dot in the middle open or is it closed? If it's closed, we're going to multiply. And if it's open, it's a composite. Okay. So be aware of the distinction. Usually if we see this, I'm going to turn it into this because I think this is a little bit more clear when it's trying to tell us what to do. So let's talk about the two types of problems we're going to see today. We're going to see a simplifying, or this is just a straight composition problem. They're going to look like this. Okay. The way you can tell it's a straight composition problem is because the inside here is an x. The other type of problem we're going to see today is an evaluating problem. And evaluating is a fancy way to say plugging a number into x. So instead of the inside being an x like this, the inside will be a number like that. This is an evaluating problem. This is a straight composition problem. Okay, so let's talk about the simplifying or the straight composition problems first. First, we're going to stretch out the first function. All that means is that if I have something like f of x equals x plus 2. I'm going to replace the x with a set of parentheses, so I have room to put something else inside. So it'll look like this. Okay, we're going to stretch it out, leave a lot of room in there to put something inside. Then we're going to plug the second function into it. So we would take our g function and put the whole thing in there. So if g of x is 3x plus 1, then we would go ahead and put 3x plus 1 inside of that. Then we would just simplify this big expression here. Okay. If we have an evaluating problem where the inside of our problem is a number instead, so we have something like f of g of 3, what we're going to do is we're going to take the number and we're going to plug it into the inside equation. So if g is something like 2x plus 1, we would plug the 3 into the x and evaluate this, and we get a number. In this case, it would be 7. Then we'll take whatever this answer is here and plug it into the outside function. So you're going to evaluate the second function, or the inner function, first. We're going to plug the number into the inner function. Then we're going to use that answer as the input for the first function, or the outer function. Okay. All right. So now that we've gone over the steps, let's go ahead and look at some examples. We'll do a few of them together so that you get the idea for what's going on. And then if we need to, we'll talk about any weird stuff. And then off you go to do your own practice problems. You're going to have an assignment entirely for simplifying and an assignment entirely for evaluating. All right. So let's look at these examples here. It says, given f of x equals 2x minus 3, and g of x equals, what color do we want? How about blue? X plus 4. They want us to find f of g of x. So because we don't have a number here, we're going to start with the outside function, f, that's an f, and we're going to expand it, and where the x is, we're going to replace it with parentheses. So this is going to be 2, where the x is, we put a big set of parentheses because we're going to fill them in, minus 3. Then we take the inside function and plug its expression into those parentheses. So we have x plus 4. Now we just need to simplify this. So we have a 2 on the outside of the parentheses. That means we have to distribute our 2 in. So 2 times x is 2x, and 2 times 4 is 8. We haven't used this minus 3 yet, so bring it down. We can't just get rid of it for no reason. Now the 8 and the minus 3 are like terms, so we can combine those. So 8 minus 3 is 5, and our answer is 2x plus 5. And that is the composition of f of g of x. This is your answer, and you're done. All right, let's look at another one. The order for this definitely matters. Notice that this is an open circle. That's telling us we're doing a composition function and not multiplying. And because the g is first, the g is the outside function, like the f is there. So this is the same thing as g of f of x. Because the g is the outside now and f is the inside, it changes the order we write these down, and it'll change our answer. So let's go ahead and write our g function out, and where the x is, we're going to put a big set of parentheses so we can plug f into it. So writing the g function first, this is where the x is, parentheses, bring down your plus 4. Now we're going to plug the f into the parentheses because we can see the f is inside the g function right there. So we're going to go ahead and grab the f function, the whole thing, 2x minus 3, and put it inside the parentheses, 2x minus 3. And now we need to simplify this. We don't have anything in front of the parentheses this time, so there's nothing to distribute. So we can go ahead and get rid of these parentheses. So we have 2x minus 3 plus 4. And then we're going to combine our like terms of negative 3 plus 4. Negative 3 plus 4 is 1. So this is going to be 2x plus 1. And we can see that we get a different answer when we compare it to f of g of x. So the order definitely matters. All right, so that is just simplifying. That's a regular composite function. Now we need to look at evaluating if we have a number in here. Notice for these, we worked from the outside in. We wrote the outside function first, then we put the inside function inside of it. If we're evaluating, we're going to work from the inside out. Okay. So if we look at our steps here for evaluating, it says evaluate the second or the inner function. So that means we're going to plug in this number to this inside function. So let's go ahead and do that. F of 3 over 2 means we're going to take our f function, 2x minus 3, where the x is, put parentheses, minus 3, and we're going to plug in the 3 over 2 to the parentheses. We're plugging in a number now instead of a function. Now we need to simplify this. 2 times 3 over 2. The times 2 cancels this divide by 2, and we get just 3. Then we bring down our minus 3, because we haven't done that yet. And 3 minus 3 is 0. So f of 3 halves equals 0. Now we take the answer from this part of the problem, and we're going to plug it into the outer function. So we're going to do g of 0 now. And the place we get that 0 is from the answer of evaluating f of 3 over 2. So we're going to do g of 0. So we're going to go look at our g function. It is x plus 4. So where the x is, we put parentheses plus 4. And now we're going to plug in the 0. Then we just simplify this. So 0 plus 4 is 4. So this is our answer. Notice when we plug in a number, we get a number. When the inside is an x, we get something with x's in it or an equation instead. That's not quite a bracket, but oh well. All right. Let's go look at a couple more examples. And then we'll do a couple maybe off of your homework. And then maybe we'll look at the challenge problem and this math attack problem. All right. So we want to do g of f of negative 23. So what we're going to do is we're going to plug negative 23 into the f function. Then we're going to plug that number into the g function. All right, so let's go ahead and plug in negative 23. So we're going to have f of negative 23 equals the cube root of negative 23 minus 1. That is the cube root of negative 24. And we can't simplify this. This is kind of stuck the way it is. So what we're going to do is we are going to take this now and plug it into the g function. So we're going to do g of the cube root of negative 24. So where the x is for g, we're going to put some parentheses, cubed, plus 1. Then we're going to plug in the answer from our f problem. So we're going to have the cube root of negative 24. Okay. Now, part of the reason we left this as the cube root of negative 24, instead of putting it into a calculator to try and simplify it, this doesn't simplify nicely. You get a really ugly decimal. But if we leave it like this, just like square roots and squareds are opposites of each other, they cancel each other out. cube roots and cubes are opposites of each other or inverses of each other, and they cancel each other out. So this cubed cancels this cubed root, and we get negative 24 plus 1, and then negative 24 plus 1 is negative 23. Okay, so that's weird. If I plug in negative 23, I get negative 23. That's because these are what are called inverses, and we'll learn about that in the next lesson. But let's look at the composition of these two functions. We're going to do f of x with g of x, or f of g of x. This is the same thing as f of g of x, like that. So we're going to take this g function and plug it into the f function. So we're going to start by writing our f function, and where the x is, we're going to put parentheses. So we're going to have the cube root of parentheses minus 1. And then on the inside of those parentheses, we're going to put the g function. So we're going to have x cubed plus 1. Now these parentheses don't really do anything, so we can go ahead and drop them. So we're going to have the cube root of x cubed plus 1 minus 1. And then we can see that positive 1 minus 1 is 0. These cancel each other out. So we have the cube root of x cubed. And then just like we talked about over here, the cube root cancels the cubed, and then we're left with just x. So f of g of x equals x. So whatever number you plug in, that's what it's equal to. So if we plugged in 13 here, the answer would have been 13. That's because g and f are called inverses. And we're going to spend way more time talking about this in the next lesson. But it's kind of like foreshadowing or a sneak peek of what you're going to see next time. All right. These are homework questions, it looks like. So let's go ahead and deal with them just to make sure that everything works out. This question is asking us to do this same thing, except reversing the f and the g. This time we're doing g of f of x. So just for good practice, we're going to write down the g function first, the outside function, and where the x is, we'll put parentheses. So we're going to have parentheses cubed plus 1. Then we're going to copy the f function to the inside, because the f is on the inside of this. So we're going to take this whole thing and put it on the interior. So we have the cube root of x minus 1. Now we're going to simplify this. So the cube root cancels the cubed, and we get just whatever's inside the cube root. So this is going to turn into x minus 1 plus 1. Negative 1 plus 1 cancels each other out because it's 0, and we're left with just x again. So g of f of x is equal to x, and that's again because they're inverses. So because we know this, because we know that the composition of f of g of x is equal to x, instead of going through all the trouble of plugging 2 into g and then 2 into f, we can use this answer right now. If f of g of x equals x, then if we plug 2 into this x, that must mean that our answer here is 2. So sometimes it's nice to do the composition function first because it lets you take a shortcut. This was a lot of work. If we had done the composition first and seen that it just equals whatever x is, then we could go, oh, x is negative 23, the answer is negative 23. X is 2, the answer must be 2. All right. We're going to go ahead and look at one of these. We're going to look at this one, just because I don't want you guys to freak out when you see a squared. And then we're going to move into this math attack problem. Okay. So we're going to do f of h of x. F of h of x, that means f on the outside, h on the inside, x way on the inside. So we're going to plug h into f. So we're going to write the f function first, where the x is, put parentheses. So f of h of x is equal to parentheses squared. Now what we're going to do, let's use that one, is we're going to put the h function on the inside. And h is just x minus 4. Now, sometimes when students see this, especially after a long holiday or they haven't taken math in like a year and a half, they look at this and they kind of panic and they go, I don't know what to do. So what we're going to do is square it. What squaring means is take this thing and multiply it to itself. So the way we do that is we take this, write it twice, and then FOIL. So anytime you see this squared, we're going to write it twice, and then we're going to FOIL or distribute, whichever way your math teacher said it before. So we're going to do x times x is x squared. X times negative 4 is negative 4x. Now we're done with this x. It's multiplied to everything in this parentheses. Now we go to the next term. Negative 4 times x is another negative 4x. And negative 4 times negative 4 is positive 16. And now we can combine like terms. Negative 4x minus 4x, that's negative 8x. The x squared and the 16 don't have like terms, so we just drop them both down. So we have x squared plus 16. This is your answer. All right, let's move on to this math attack problem so that we can tackle the really hard stuff, and then you can go ahead and try these on your own in your homework, and I'll be there if you need any help with them. So it says the number of bacteria B in a refrigerated food is given by this equation. So here's the number of bacteria. It depends on C. We don't know what C is yet, but C is some variable that they'll probably tell us. And it's this equation. The amount of bacteria is 20 times C squared minus 80C plus 500, where C is the temperature of the food in degrees Celsius. So C is how warm or cold our food is. When the food is removed from the refrigerator, the temperature of the food is given by this. C, or the temperature, is equal to 4 times T plus 2, and T is the time in hours. So this equation, we have to plug the temperature in, but to get the temperature, we have to know how long it's been sitting out for. So they have a couple of questions for us to practice on. It says, calculate the number of bacteria that are in the food after removing the food from the fridge for 0.5 hours. So we can't plug the 0.5 in here. The 0.5 is hours. That's telling us a time. This is temperature. We can't go straight here to figure out what number of bacteria is on our food. We have to do a pit stop and go figure out how warm is our food first. So what we're going to do is we're going to take the 0.5 hours and we're going to plug it into the time in the temperature. So we're going to start by doing C of 0.5 equals 4 times 0.5 plus 2. 4 times 0.5 is 2. Plus 2 is 4. So C of 0.5 equals 4 degrees Celsius. Okay. Now we know our temperature is 4. That's what we plug into our bacteria equation. So let's go ahead and plug the 4 into C here, and then we'll simplify. So we have B of 4 equals 20 times 4 squared minus 80 times 4 plus 500. 4 squared is 16, and 16 times 20 is 320. So this whole thing here is 320 minus 80 times 4 is 320 plus 500. So 320 minus 320 is 0. These cancel each other out, and our answer is just 500. Because this is a word problem, we should make sure we put units on this. 500, what is B measuring? It's the number of bacteria. So we're going to say 500 bacteria. And there we go. So what we should maybe notice here, you're going to say, Mr. Barton, this has nothing to do with what we just learned. Notice, we plugged a number into this function and then took its answer and plugged it into this function. You are doing a composite function here. What you're really doing is B of C of T, right? You're plugging the temperature into your you're plugging your time into your temperature equation, then taking that answer and plugging it into your bacteria equation. You are doing a composite function, and we're just doing it step by step. Let's do one more here. It says, calculate the number of bacteria that are in the food after removing the food from the refrigerator for 2 hours. So it's the exact same thing we did here. We're just using a different number for time instead of 0.5. So we're going to do C of 2. We're going to plug our time into our temperature equation first. Equals 4 times 2 plus 2. 4 times 2 is 8, plus 2 is 10. Then we're going to plug this 10 degrees Celsius into our bacteria equation. So we're going to do B of 10 equals 20 times 10 squared minus 80 times 10 plus 500. So all I'm doing is plugging in the answer from our temperature equation to the C's here and here in the bacteria equation. Now we need to simplify this. 10 squared is 100 times 20 is 2,000. 10 times 80 is 800. So this is going to be minus 800 plus 500. Then I would just type this whole thing into your calculator. So 2,000 minus 800 plus 500. That gives us a total of 1,700 bacteria. All right. So now it says this food item is considered unsafe when there are 3,300 bacteria present. Estimate how long it will take to have that number of bacteria and the temperature of the food. Okay, this is actually a very tricky problem because they're asking us to work backwards. They're saying B of C, which is 20. Let's back that up a little bit. Whoops, too far. B of C equals 20 times C squared minus 80 C plus 500. What they want us to do is figure out when does this equal 3,300. Okay. So what I would do for this is I would take this thing and maybe go to Desmos. Okay. You're going to have Desmos. Type in 20 parentheses squared minus 80 parentheses plus 500. Okay. Then we can go ahead and plug in different numbers here. We already tried 10. That's a little bit too low. We don't have quite enough bacteria. So we saw if it was 4 degrees, it was 500. If it was 10 degrees, it was 1,700. So as the temperature goes up, so does our bacteria. So what we're going to do is we're going to just guess numbers and plug them in and then try and figure out where does it go past 3,300. So let's go ahead and plug in some numbers. I went ahead and did these kind of off to the side because I don't think you really want to sit and watch me just plug in numbers to this and simplify a couple of times. But I'll tell you what I got. So when I plugged in 11 gave me 2,040 bacteria. I was like, all right, that's actually really close, right? We went up 400. I probably don't need to do that many more times. So let's go ahead and try 12. I plugged in 12 here, so I went 12, 12. I got 2,420. Then I tried 13. I got 2,840. And then I plugged in 14, and I got exactly 3,300. So what that tells me is that when my temperature, C of T, equals 14 degrees Celsius, then my bacteria is 3,300 bacteria. Okay. The way I got this is by just plugging in different numbers to C in this equation using Desmos. It was pretty quick, but if you need help with the calculator, let me know. We can go over it in class if you would like. Then it says estimate how long it would take to have the number of bacteria and the temperature of the food. So the temperature of the food is actually a lot easier to get because we know how to solve this equation. So we have our equation. C of T equals 14 degrees Celsius. It also equals 4 times T plus 2. We can definitely solve this equation. We don't have to estimate at all. So we have 14 equals 4T plus 2. We want to get T by itself. So let's start by undoing this plus 2. So we're going to subtract 2 on both sides. These cancel, and we get 12 equals 4T. Now this 4 is multiplying to the T. So to undo that, we need to do the opposite. So we're going to divide by 4. And if we do it to this side, we have to do it to this side. We're going to divide by 4 again. So these cancel. We get T on this side, and then 12 divided by 4 is 3. So when T equals 3 hours, that's when our bacteria is at 3,300 bacteria. Okay, that's everything you need to know for today. Keep in mind we did 2 lessons and it only took half an hour. If we were in real class, like in a classroom right now, you'd be 50 minutes into the first lesson still. We're making really great time, you guys. I understand that we did a lot of crazy stuff. We learned 2 lessons. We did this big word problem with composition functions. We guesstimated how hot our food has to be to have the right number of bacteria. Then we reverse that to get how long it takes. This is a lot of material. If you need help, go to the WebEx, open your homework, and try it. Okay. When you get stuck, unmute yourself on WebEx. Say, hey, Mr. Barton, can you please help me with this homework problem? I'm a little bit stuck. And I'll say, absolutely. I would love to help you. It's literally my job. So go ahead, hop back in the WebEx, open your homework, and let me know if you need any help. I'll see you guys next time.